All right. So any questions from homework stuff? No. So what I do with homework that some of you guys got homework back from me already. So if you give me homework before the review day for the test, I get it back to you so you can use it for study. It's crazy. With notes or whatever I wrote on there. If you give it to me the review day or the day of the test, I grade it whenever I can. And what I normally do is I go back and grade the people that made below average on the test, just to show why maybe you did that. So as I'm putting the homework in the computer right now, just to make sure it's been turned in, I'm noticing it's not really the best. There's answers appearing out of nowhere. Some of you guys didn't do any of the standard deviation work. Somebody wrote, I just did this in the calculator, and I'm like, that's some balls right there. You know, that's no good. You don't learn shit if you do that. Yeah. I mean, there are typos in the back, but I don't remember any from that section. So you'll want to double check with me the work you did. Yeah. Yeah, you could do that after class or in my office during my office hours. Yeah. I like it. Cool. So anything else about any technical issues or anything from homework stuff? Okay. So last time, let's see. Let's kind of review what we got through so far, what we know so far, and then I'll try to firm up what we don't know. We'll do that last problem, and then maybe we'll take a look at the other side of that. So what do we know so far? We know, for example, we know this formula. What is OR? OR is basically what? Add. Because remember, OR is the nice bouncer. It says you could be in this group or that group, and it keeps adding more people in as long as they meet at least one of the conditions. More and more and more and more. It's adding. And is the one that's basically multiplying. Right? So which is always going to decrease. Right? Probabilities are like 30%, 40%. So if you multiply two probabilities together, it's going to get smaller. 40% of 20% is 8%. Holy shit. So it's just going to get smaller, 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 and is the evil bouncer. Less and less people can get in. All right, so I'm trying to give you ways to remember this stuff. So probably, what is probably A? Well, it's probably A plus probably B, like we said. Well, what's the little adjustment we make? Minus? Probably A and B. I like it. Because if I add both of these together, I might have added two things twice, right? I might have added something twice. Okay, I like it. Quick little example. It's cool. I can throw some definitions here in the middle of review. So remember the deck of cards thing. This is going to be a very simple question, even if you don't know cards too well. If I pick a card, what's the probability I get a 4 or an ace? Yeah, so what's the probability of getting a 4? 4 4s out of 52. What's probably getting an ace? Do I have to subtract anything? Why not? It's kind of a silly question, right? Yeah. Well, if you got an ace, it can't be a 4 at the same time, or if it is, I ain't going to play with your deck of cards, right? So, oh, I got a full house now. No, don't like that. You guys with me? So this is the idea. So this piece of the formula would be 0, but it's like you don't really need the formula. You would just say 8. There's 8 things that match what I'm looking for. Why do I have to adjust it? Because they don't share anything. I didn't count anybody twice. There isn't a card that could be this and this. So that idea, the fact that they can't be both, is something called mutually exclusive. Mutually exclusive. So this is a definition. I don't think I've said this yet. What does exclusive mean? What's the first image that comes to mind when you hear exclusive? Did you say Pop-Tarts? No. What is it? Say again. I like, all right, because the first thing that comes to my mind is Jeff trying to get in somewhere, and they're like, it's a black tie, sir. Oh, shit. I don't have a tie at all. right? So that's exclusive somehow. It's like an exclusive club or an exclusive group, right? Like Mensa. You can only get in there if you have an IQ greater than whatever. And then they all sit around staring at each other. I don't know. Are you guys with me? So exclusive, we understand what that word means. Mutually. What does that word mean? Mutually. If we come to some agreement mutually or... Together. All right. So that means that this mutually exclusive means that we both exclude each other. So the club says, you can't come in here. And I'm like, yeah, you can't come in my house either. So we mutually exclude each other. So what this really means is, just like the 4 and the ace, can any 4s be aces? No. Can any aces be 4s? No. They mutually exclude each other. So if two things are mutually exclusive, they can't be both. All right, if A and B are mutually exclusive, that really means there's no intersection. They can't be both. So the probability of A and B would have to be, what's the probability that you find something that's both? If it's impossible for them to be both. And is multiply in general, but this is an idea. I mean, if it's impossible to be both of these, what's the probability of finding something that is both of them? 0, right?
I know it's a philosophy.
I used to use dogs and cats, and then there was a cartoon of cat dog, and then we don't want to get the biology of that because it gets really disturbing. Now I use salamanders and ice cream, or rocks and ice cream, or something silly, right? If I have a rock, I don't care how much you wish it would be. Is it ice cream? No. So that's mutually exclusive. Something easier is 4 and ace. If you are one of them, you can't also be the other thing. Are you guys with me? Not that crazy of an idea. Very simple, actually. So if in the book, in the homework, they're going to say something like, A and B are mutually exclusive, and then they're going to continue and ask you questions, don't just blow past that sentence. Immediately write this. So if there was a problem that said, event E and event J are mutually exclusive, what can you immediately write down? E and J are mutually exclusive. What can you write down? What do you know is true? Probability of E and J equals 0. Thank God. Okay, all right. Basically, this thing I just told you, right? Okay. So you're writing down something useful. They're going to ask you to calculate things, and maybe the calculations require you to know this, and that's where people go, they never told me that. No, they too tell you that. You have to write it down for yourself. Translate from English to probability-ish. All right, so that's the idea of mutually exclusive. That means they cannot occur at the same time. I like it. Okay. So what's the probability of A given B? What was that formula? That's the formula we developed. Okay, that's the symbol for it. So I that's the symbol for this. That's not really the formula, though. I do appreciate that, though. I appreciate that. This is another way you're going to see it in the book and from me. That dash means given. It doesn't mean divide. Doesn't make any sense.
P, A, and B.
Yeah, A and B.
Over B.
Over B. That's right. So if I know B happened, I focus my attention on B. That's why the denominator becomes associated to B. And if B happened, the only way A also happened is if it's in B. If it's A and B. That's the only way. So if I said, what's the problem? I got a man, given that they're a Democrat. What's the only... Oh, a little more faith in us. We're not all silly. What's the problem? I got a man, given that it's a Democrat. Well, the only way that you can be on the top, the only way you can be counted is if you are a male Democrat, right? Because I know it's a Democrat. So the only way you can also be a man is if you're a male Democrat. If you're a man and a Democrat. So what I'm saying is you don't just blindly memorize formulas. They actually have physical interpretations, always, believe it or not. And the more you understand the idea behind it, the less you just straight up memorize this shit. I only have so much room in my brain, and I'm able to do a lot of stuff. I don't memorize everything. I try to see why it makes sense. Okay. So what about, and then from this we developed the formula for this guy. You remember I wrote it both ways. Remember we did a little tiny bit of algebra? The tiniest bit. We just multiply this sucker up. Or you can write it as probability of A times probability of B given A. It's the same idea. So it's probability of 1 times the probability of the other one given that other guy happened. And this, what kind of problem did we do where we kind of forget that the formula says the same thing? Well, what if I pick 2 cards without replacement? Get 2 kings. It would be 4 out of 52 times 3 out of 51. The probability is a king given that I already picked a king. That idea kind of makes sense by itself, and then you go, oh shit, it's the same thing the formula says. Oh, okay. I trust the formula a little bit. All right. The idea associated with this we already talked about. I don't think we had talked about this until today, but the idea associated with givens is the idea of independence. How can I check to see if 2 things are independent? Oh, this is going to take some getting used to. Test for independence. All right. Well, this is the thing that no matter how much I say what I'm about to say, people still don't do what I say. You cannot ever answer this question with a paragraph. Well, you see. No. You have to show me math. You can say some words, don't get me wrong, but you've got to base it on the math. It's a mathematical idea. So what is the test? I really wish to God this would make total sense. If B happens, right? Is that cool? Given B. And A don't give a shit. What does that mean mathematically? What does not give a shit mean mathematically? It stays the frickin' same. The probability of A, given that B happened, if it's the same as what the probability of A was before B happened, then obviously A doesn't care about B. They are independent then. If that's not true, they're dependent. What's up? I had an extreme reaction there in the back. You all right? You don't know, okay? Please let this make sense. If B happens, and the probability of A doesn't change from what it was before, it's the same as what it was before B happened, then obviously A isn't affected by B. Yes. I like it. Now, what I always get is somebody tells me, well, the probability of A does not equal the probability of B, therefore, what the shit? Why does it matter that their separate probabilities equal or don't? You have to see how they affect each other. Does it affect each other? I have to do the given. That's the thing that shows me how they affect each other. You with me? So given that it's, I don't know, given that I forgot my coffee this morning, what's the probability that I make mistakes in class, right? It goes up. The probability I make mistakes goes up, right? You with me? Or given that you didn't sleep at all last night, what's the probability that you're not really paying attention? It goes up. Yep. Are you with me? Some of you guys are like, I am living that example. Okay. All right, please. Don't just, if you have to just memorize it, okay, but please let that make sense. I mean, that word independent actually matches the idea of what we're talking about in English. What would it mean to be independent? Well, this guy does something and the other guy doesn't care. Doesn't care. Okay. All right, maybe. Okay. All right, so this is basically everything we did already. Just the mutual exclusive was new today. Okay. All right. So let's do a little bit of sort of new stuff.
Are we going to try them with numbers now?
Say again?
Are we going to try them with numbers now?
Oh, Jackie's like, give me something concrete, boy. All right. We will. We did the other day. All right, let me do this, and then we'll see about an example.
It's confusing.
Okay, here. Let me make a really quick example. Really, really quick, easy. Sing it? Dude, I have no idea. Sorry. I just do chapter 3, right? The way the book organizes it isn't exactly the best way to teach it ever. It just, they all kind of intermingle. I don't know if you noticed, but the first day we talked about probability, I did parts of every section. Right? I didn't do that because I'm evil. I did it because it made sense. As I'm doing stuff, it makes sense to talk about this other idea, which they put in a different section. I'm really sorry, I have no idea what section. It's going to be a few sections here. All right, so this is sort of like what we did before. Let's see. All right. So I'll always give you, if I give you a problem like this, I'll give you these outside blank ones in the hope that it reminds you what to do. The probabilities are always based on totals and counting. So you want to sum stuff up for whatever kind of question I ask, right? So let me see, how many people said yes? 8. How many people said no? 32. How many people are there? 40. How many men are there? 10. How many women were there? 30. Thank God that makes 40 also. Right? Just don't put 80 there. Have 40 people materialize in a freaky way. I like it. So I can ask you, let me just jump to the good question, which probably that they said no.
32.
Yeah, 32 match what I'm looking for. Out of how many could have happened? 40. Because I didn't tell you anything. I didn't give you any information. So who could it have been? Any of the 40 people. What's the only time the bottom changes? If it's a given. If I give you information, you can exclude people from your consideration, right? So here, on the heels of that. What's probably, they said, no, given it's a woman. So what do you know about the person? It's a woman. So what's going to go on the bottom? Out of those 30 women, how many said no? 24. Now help me out. What's 32 divided by 40 as a decimal or a percentage? Yeah, so it's 80%. And what's 24 out of 30? It's 80%. Yeah. Right? If you 24 divided by 30, my hand's out of batteries. Okay. 80%. So help me. I can answer the question right now. Are being a woman and saying no, are they independent? Why? I like it. So on a test, you're going to say, yes, independent. The probability of no equals the probability of no given woman. A 0.8 equals 0.8, or 80% equals 80%. This is all you'd have to do. This is it. Not very many words at all. You could have a few more words, but you better freaking have this, because that's the only way to accurately answer that question. It's a mathematical idea, this independence and probability. So you can't just go, well, you don't have to be a woman to say, no, that has nothing to do with this. It's taking it too extreme. I didn't say you have to be one to do the other. No. Does being one affect the probability of the other? No. Yes?
It's a different answer, does it? It's not...
Yeah, so if I would have gotten 75% here or something, it would have been dependent.
Okay, so they have to equal the same.
They have to be the same exact number to be independent.
Okay.
I like it. I like it. And we've seen that before. And so the example we did, number 1F on the side we did in class, that was an example of dependent. Why? Because the given didn't equal what it was before. It changed it. I like it. Okay. So with the early response, given that you're a woman, does the probability you're a Democrat change? Yes. Right? More Democrats are female. This is true. Because more women are rational. Most of the time. Okay, John, just stay away from that. Does everybody understand this example? I don't know if you guys noticed how I tripled this, and that's what made the ratios come out the same.
No.
That's fine if you did. I just want to point that out. That's how I can make one that I know is going to be independent if I keep all the ratios the same. Okay. So here's the part from the in-class worksheet that we didn't really cover yet. So let me try to do this a side-by-side comparison. If I had, say, 10 people, let's say 4 women, 6 men, okay, and I pick 2. Without replacement. What's probably I get a woman and then a man. All right, so this is related to that. We did one of these kind of things before. Somebody help me out here. What do? I'm going to put down how many? I'm going to put down a couple of places here, right? Why do I put a times here? And is basically multiply. It's probably a first person is a woman. 4 out of 10. And you send them away, right? Push them off the train, whatever. What's probably the next person you pick as a man? Yeah, so now there's still 6 men, but there's 9 people, right? So then what do you get here? 4/15. I don't know what that is.
0.26.
0.26, like 26%?
Yeah.
0.26. Now, I want to focus on this right here. Real quick. What's probably as a man just by itself? If I just pick one person, what's probably get a man? 6 out of 10. How different, and what's 6 divided by 10? 60%, right? What is this? What's 6 divided by 9? If I pick one person and the next guy is a man, it's going to be 6 out of 9. What's 6 divided by 9? 66.6. The evil percentage. Boop. Would you say that's a decent change from 60 to 66? Yes, I would. Yes. Wouldn't you much rather have this as a grade than that? It's not good, but it sure is all hell better than 60%. Right? And if my surgery went from a 60% chance of success to a 66%, I would feel better. If it went from 60 to 60.1, I'm like, okay. It's not that big of a change. So what's my point? My point is, if I have a large population, was this a large population of people?
No.
Hell no. When we have a large population, when we have a large population, we do not have to continue to change the probabilities because they're not going to change that much. So, for example, help me out. Somebody get their calculators ready. If we had 4 million people, and let's say that, I don't know, Jeff, 50,000 of them or something, right? The probability, let's say the probability of a left-handed person in this population is there's 50,000 out of 4 million. What's that going to be? 404. 12.5%? Yeah? 0.125 or is it 1.2?
0.125.
Okay, so 1.25%. Okay. Oh yeah, okay. So far so good? Now what if I lose one of them? Like it's a problem like this and I picked one and now there's one less. Are you with me? There's one less. So now there would be 49,999 out of 399,999. Somebody help me out. Do that in the calculator. What is that? Is everybody with me? I lost one, so it would be like what we would put here.
0.124.
Yeah. 1.24. Oh my God. Do you guys understand? So, here's an immediate, concrete example of what I'm trying to say here. Obviously, it did not change that much at all. It really didn't change basically at all. Right? So I don't have to do this kind of thing when I'm doing it without replacement. So here's an example of what I'm talking about, and then we'll do the one that's on the worksheet. Did you know, what's the example on the worksheet? Let me not do the same kind. Okay, that's good. Whoa. Yeah, okay. So let's say that we know that 11% of Americans are left-handed. And I picked 2 Americans. What's probably that they're both left-handed? Now, dear God, no, don't write this down. Do not write what I'm about to write. Don't write it down. Just tell me why it is so desperately wrong. 11 out of 100 times 10 out of 99. What's the bottom supposed to be? No. What's the bottom supposed to represent in a percentage, in a probability? Total number of things it could be. Now, are there 100 Americans? No. That would be freaky. I mean, we all die quickly. It'd be like the Stand, if you ever... Yeah, all right. Weird-ass virus takes most of us out, and the rest of us are fighting the zombies, and fences aren't working the way they're supposed to. This is wrong. Please, dear God, no. Now, please, dear God, don't look up how many Americans there are currently, the population of America, and put that. No. The point that this makes is that what's probably the first one's left-handed? 0.11 times. What's probably the next one's left-handed? 0.11? Because would it change much? It would even be better than this, because how many Americans are there? There's like 350 million. Are we near there now? I don't know. Do you guys even realize? No? Okay. You guys see what I'm saying? I don't have to make ratios and change the bottoms and the tops and stuff if my population is huge. Because they're not going to change. They're not. So what's 0.11 times 0.11? Yeah, isn't that neat? So that would be like 0.0121? Yeah. And if you did, is everybody cool? That would be 1.21%. Multiply by another 0.11. 1331.
As a percent?
Yeah, 0.11. Yeah.
1.331.
All right, sorry. 11's kind of freaky. What it does, it doesn't need stuff. Okay, so look at the number 3 on the worksheet. Beside it says in class. Yes, ma'am. Okay, good. When the sample size you're picking, all right, here's the official definition. I always make it really, really all the way one way or the other. But if you want to talk about the official definition, when the sample you're picking is less than 5% of the population. So how big of a sample did I pick here? 2. That is definitely less than 5% of the population, so I'm allowed to just do this. I don't have to worry about changing the bottoms. But I'm always going to make it really, really like totally one or totally the other. You with me? I'm not going to put it to the point where you got to go, oh my God, okay, am I allowed to? No. But there is an official definition, that's it. Okay, so try to do the last problem. You could at least do 3A, and then I want you to think about how to do 3B. You know, and the one that says this side in class, number 3. 3A, do that one right now. And try to think about 3B. Anybody need that handout still? Everybody's got one? You good? You stretching? Okay. So let me make sure you guys are on the right track. 3A, how many blank spots are you going to have?
4.
4. You got 4 people, right? So it's the first thing to make sure you got down. I always get people that make 3 and there's 4 people. I'm like, oh my God. Also, 9% of Americans have a favorable view of North Korea. So how many have an unfavorable view? 91%. I like it. Make sure you do that math correctly or else everything's kind of thrown off. Right, let's turn you around. You gotta be careful with B. B is still 4 people, right? We'll talk about B. Guys, if the probability it was going to rain today is 10%, what's probably it's not going to rain today? 90%. Isn't that stupid easy? Opposite probabilities are always 1 is 100% minus the other, or 1 minus the other in decimals. Are you guys with me? What is the opposite of at least 1? If I said at least one person in here likes statistics, how could you show that I'm wrong? You'd have to show me that nobody. So the opposite is always what is left out. At least 1. The only thing at least 1 leaves out is none. And how do opposite probabilities relate? 1 is 1 minus the other. So somehow I could put all that together into a really kick-ass way to always do at least 1. That's all right. So what's the first one's not too bad, right? It's basically just like the ones we were doing. I got 4 blank spots. The first one views them favorably. So what number I'm going to put here? 0.09. And now the last 3 don't view them favorably, so they all have to be 0.91, 0.91, 0.91. And then you just throw that in the old calculator. Now notice, how can I rewrite this? This seems kind of like silly, but it's not. It's kind of awesome.
Why is it 0.1?
Point who?
I mean 0.91. Why is it?
If it's 9% that do, what percentage doesn't? 9% do. What percent don't? What's left over?
91.
91%, which is 0.91. All right. Watch. You guys have the answer, right? You put it in the calculator. But real quick, couldn't I write this as 0.09 times 0.91 to the third power? So isn't this like 0.09 to the first power? So doesn't it say 3 of these and 1 of those? That's going to become very important to us in a bit. Now, right now, it doesn't really matter. Just throw it in the old calculator. What do you guys get when you throw it in the old calculator? 0.0678. Neat. I'm easily immune to bets, right? Say again?
We didn't get that.
Really? Okay, let me double check. I always crowdsource my answers. Let's see what if I 8, 7. There should be some kind of a 6. That part I agree with. 0.09 times 0.91 to the third. I get that. Uh-oh.
It's okay.
You got it?
I'll redo it. I did it like last class. So
Oh shit. Okay. You set it up like this though, right?
yes.
Okay. Now, let me see if I can give this to you a different way. So tell me, if we have 4 people, how many of them could view North Korea favorably? How many? People always forget the fact that none of them could, right? So I have none of them could, or how many? So none could, or 1, or 2, or 3, or 4. And that's got to equal what? If I add up all the probabilities, I better get freaking 1. 100% or 1 as a decimal. You guys, is everybody with me? All right. Really stay with me now. This is kind of silly on one level, but you guys, does everybody see where that's all coming from? That's all the possibilities for. Let's happen. Please do now. We gotta start somewhere. So, how many people out of 4 could view them favorably? None through up to 4, right? Can't have 5 of them view them favorably because I'm like, who the hell is more than one person? It's freaking me out.
Is this
You
for
have multiple
B?
personalities. You're still one person. Yes.
Is this for B?
Yes. Cool. Trying to build up to it. All right. Can you underline the part of that that relates to at least 1? Which ones relate to at least 1? All right. I love the fact that some of you guys are living like, well, shit, man, that's easy. That's not easy for everybody. All right. There's at least 1. Is that cool? So if the question is asking me to calculate this, couldn't I just do 1 minus this dude? How do I solve for this? Minus that. 1 minus the probability of none equals the probability of at least 1. Why does that make sense? Because they are opposites of each other. Just like rain and not rain are opposites of each other. Just makes sense. In fact, it's not just true for at least 1. It's any time that you have the probability of something and the opposite situation is easier. Now, real quick, some of you guys might be like, what the shit, dude? There's only like 4 things to do. But how many ways could you have one person view North Korea favorably? It could be the first one, or the second one, or the third one, or the fourth one. So there's 4 things to do just for P of 1. How about P of 2? It could be the first 2, or the last 2, or the first one and the third one, or the first one and the last one, or the second one and holy shit, right? How much work is involved in what I've circled? A lot. What's the opposite situation? 1 thing. So anytime that you have a probability question where the opposite situation is easier to calculate, shit, yeah, I'm going to do 1 minus that easier thing and get the original question. The probability of something is 1 minus the opposite. Just like the rain and not rain. It's exactly the same idea. Okay? So here, how do I do this then? How do I figure out the probability of none? None of them view it favorably, so they all what? None of them view it favorably. They all don't view it favorably, right? So each one of these spots would be what? 0.91. So that's the probability that none of them view it favorably, otherwise known as all of them don't like North Korea, right? Okay. That's not going to answer the question, though. How do I make it answer the question? I do 1 minus that. Because that would be everything else. So if I calculate the probability of none, how do I get the probability of at least 1? 1 minus that. Because that's everybody else. So what do you get for this? This one should be like 0.6 something. Who is it? 6857. Is that what you guys got? So now to answer the question then, I'm going to do 1 minus 0.6857. And watch this little trick. I know you guys have a calculator. I know you guys don't want to ever figure out how to do it without a calculator. Some of you guys have already put in the calculator. That's great. But here's a really quick way to do 1 minus a decimal like this. Make all these become 9. What makes this become 9? 3. So 0.3, 1, 4, and then make the last one 10. 3, 1, 4, 3. Is that what you guys got, whoever did it already? All right. Without interaction, I'm going to go crazy. Right? Yeah, so 0.3143, if you do that in the calculator, that's what you should get. 0.3143. It's a really useful little shortcut, so you don't have to always rely on the calculator. You could feel a little bit better about being a human. Yes?
Why is the last one 10?
The last one 10? Where? What?
If you're subtracting it like without the calculator? why-
Oh, okay. So the reason that works is related to the fact that when I subtract 2 things, like if I had to subtract 8, 7, 8, 2, or even just, let's make it easier, if I had to subtract 41 minus 19. That's the same thing as 42 minus 20. Right? If I make that go up 1 and I make that go up 1, I get the same answer. So that's actually a trick how to subtract things when it's really close to nice whole numbers or something. Right? So in fact, you can use the same idea. If I had to do 7,000 minus 5218. In fact, this is going to explain exactly why this works. This sucks a lot. If you have to do this by hand, why would it suck a lot? Because you got all this freaking borrowing to do, and you got to remember to make it 9 and all this fun. Right? You with me? But isn't it the same distance as 1 down and 1 down? Right? So that's why if you look at what you get here. So if I make this become 7, this become 10, this become 9 in this case. So I can kind of extend it to be like 1000. That's what I got up there, right? 1 minus 0.6857. What I'm really doing is making it 0.9999 minus 6856. Right? 9999 minus 0.6856. So I make this become 9, this become 9, this become 9. It tells me the difference. And this becomes 10 because it would really be 1 less. All right, that's enough of that. That's enough of that. I always hate that you guys don't see so much stupid calculator bullshit because everybody nowadays says, we don't need to know how to do anything. We got stuff to do. No, it's bullshit. You want to be able to work with numbers. We invented them. We have to be able to work with them. All right. I'm not going to convince you of that in one day. But that's really cool. Has anybody never seen that before? Does anybody find it like more than 0% interesting? Yes? Okay. All right. It's okay if you have a negative interest in it. I'll deal with it. Okay. So now I forgot. We got 0.314143. No, Jeff. 3143. There you go, buddy. Okay. So there's a 31% chance about to get at least one of them view North Korea favored. Now this last problem, I would. The trick to this last problem is to give symbols to things so you see what it is I tell you and you see the formula for what I ask you. What symbol would you use for the probability of viewing North Korea favorably? Just give me a symbol you want to use. Say again? F. Okay, I like it. F for favorable. Kicks ass. So what's the probability of favorable by itself? Probability of favorable. Be careful, it's not 6%. That's Americans have a favorable view of both North Korea and Brussels sprouts. So it's probably that they have a favorable view of North Korea. 9%. That's the thing I told you at the beginning, right? Okay. And what's the probability they have a favorable view of North Korea and Brussels sprouts? I'm going to put a B for Brussels sprouts. Is that cool? What's that? Probably a favorable view of North Korea and Brussels sprouts. 0.06, because I tell you that. Okay. We're just giving them symbols. Why am I giving them symbols? So they'll match up to the formulas. Now, what is the question that I'm asking? Probably the American likes Brussels sprouts, given that they like North Korea. So what would that look like in symbols? American likes Brussels sprouts, given that they like North Korea. So likes Brussels sprouts. It's a B. Symbols. If I don't use symbols, I don't know where to put numbers. Probably B given F. I like it. Right? Is everybody cool with that? So again, you can't set up the formula so that you know where to put the numbers until you give symbols to everything. Now, what's the formula for this? What's the formula for given? So now use what we got. Probability of B and F divided by. My man up here had it. Probability of F. 11. Do we know the probability of B and F? 0.06. And do we know the probability of F? 0.09. that becomes 0.6666. You get 66.7%, roughly. So again, that's an example where, did I give you the number of North Koreans and the number of people that like Brussels sprouts? Could you count everything? No. This is an example of a problem where you have to use the formulas. You're going to see quite a few problems in the book where you have to use the formulas. So you're going to have to give yourself, or the book very often gives you symbols that represent, like they'll tell you B represents they like Brussels sprouts, and F represents they like North Korea. So now you're able to identify this probability goes with this thing, because that's what they said, and this goes with this thing, because that's what they said. You have to translate from English to Mathish, right? You can't do that until you give yourself words to work with, and these are like the words you're going to work with. Okay. Let's look at the other side here. This is a very standard problem. I really can't change it up that much. So this type of problem, you know it's going to be one like this. A contingency table, right? Here's kind of a nifty problem. Can you see, is the with replacement without replacement kind of problem? So that type of problem you're going to see. I'm not saying it's going to be set up sort of the same way, but it is going to have these words. It's going to be kind of in your face. I'm going to be picking several things. So that's where you have to do this times this times this. And maybe the next things change if I'm not putting the stuff back. So in this case, I eat a candy bar, so now I got less candy bars. This is one like we just did. Right? Talking about that, really the tax benefit over. And then this is one like the North Korea thing, but even just more only giving you numbers. Right? Just to warn you ahead of time, I did give you a hint on this part C. Part C is not a standard question. Part C is just me seeing if you can play around with shit. That's really all part C is. People focus so much on that, I'm like, it's just a little interesting side note. Okay. So this, I really want you to work at on your own. And I'm going to have the answer key next time, okay? So we're about to get into some other stuff, or we can try some homework problems out there. Let's do this. Let's take a look at the kind of homework problem I was just talking about, just so you guys are ready for it. There we go. This is, that one's not the more interesting one. Where's the more interesting one? Where are you? Was it before that? There, well, this is not bad to start with. There you are. Okay. So if you have the book, it's problem number 80. All right, these are not well designed. There's no way. I appreciate that so much. That's just awesome. Let's try to pull the book up. Oh, maybe I can do this. Turn it sideways and then yeah, this doesn't turn that way. What I can do, stupid thing. Oh my God, Jeff is using tools and shit. Is he welcome? All right, let's see. Freeze. Pull back out a little bit. Where'd it go? Where'd it go? Where'd it go? There it is. Freeze. Okay. Okay. You have the book. Read through it there, but otherwise, read through that. Do you see all the percentages they're just throwing at you? Okay. And then they ask you questions about blah, blah, blah. Some of these are just told to you directly. I always get people that try to start doing some work here, and I'm like, no, they just told you that. They told you that. So that's why a really good first step, use the symbols they tell you to use, and then rewrite in symbols the probability. So for example, that very first one, 61%. What symbol, what do you use? P of what is 61%? Yeah, so it's California registered voters who approved of allowing two people of the same gender to marry, blah, 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 blah. So voters who support same-sex marriage, right? So that would be P of C equals 0.61. And look at the very first question. It's like, all right, dude, you told me what the hell it was. That's easy to find, right? But you can't do that until you relate the symbol to the percentage. So then, let's go to the one that's a little bit freakier. What about that? This is kind of a hidden one. See where it says 6 in 10? So that, of course, is what percentage? 60%. So what's that relate to? Well, this is a good one. Yeah, so it's 60-10 California registered voters said that the upcoming Supreme Court's ruling about the Constitution of Iowa was either very or somewhat important to them. So that's going to be B. I like it. And then the one that's really interesting that doesn't use that key word. I told you they don't always use this word. That very last sentence. Figure out that very last sentence. What? 30? Out of those, what word is that replacing that we normally use? Out of those who support same-sex marriage. So, given